The data transmission. This is a huge problem because once you have data from a sensor, you have to move it in order to analyze it. So maritime data transmission has two distinctive parts. The first one is that there are different physics and there are different trade-offs. So if we take a look to the first one that is on board, from the sensor to the local hub somewhere in the ship, if you have here as a person with an electronic background, I will see that we have like different options. The first one, the most common one will be Zigbee and Bluetooth that are short, range and low power, ideal for sensor mesh networks inside cabins. Wi-Fi is a medium range and high speed suitable for transmission of larger dataset. We also have ultra wideband or UWB. It scores, a highest comprehensive evaluation because it combines range, speed, and lower latency. Also, we have NFC that is essentially useless at this scale. It ranges just, like centimeters. So this is not an option. And we also have wired options such as fiber optical, coaxial. These ones offer, the highest rate, but they are very hard to install in a ship that is already built. So this is the first problem that is on board. The second part is, you need to communicate from the ship to the shore, from the vessel to the land, over so the information can go to analytical centers. So this is where the low Earth orbit satellites come in. Systems such as Beidou satellite navigation sensor system and framework like ship emission monitoring sensors web are now the standard infrastructure. So the crucial trend in satellite communication costs are dropping rapidly, which means the continuously held monitoring of distance vessels is becoming more available for the first time. And now here is a question I want to hold in your mind for the rest of the seminar. What is the maximum acceptance latency between, like seafarers, vital sign deviation, let's say an arrhythmia, and a short base physician that is analyzing this signal? It will be maybe 5 minutes, an hour, a day, because the honest answer is that the field has not yet decided the time that it should be. And until it doesn't, we cannot fully design this kind of system. And I will come back to this at the end of the presentation. So let me go ahead. So we have in data transmission a comparative wireless evaluation. Let me give you the data behind this image. This chart is from CUI 2025 review that scored 5 wireless technologies across distance, speed, power consumption, delay, and reliability. So combine it into a single comprehensive score out of 5, and like UWB comes out on the top with 4.6 of average, well ahead of the others. It combined long range, high speed, and low latency. Zigbee scores about 3.8 and Wi-Fi 3.6. Both are, good options. Bluetooth has a 3.4, is, competitive for short range and low power application. And FC at 2.2 is, it's not an option actually in this case. For HD, HE, cases. The practical implication is that, maritime health monitoring system being designed today, UWB deserves serious consideration on onboard transmission backbone. Maybe we never think about this as an option because it's not that popular in engineering, and we have more examples of how to apply other technologies such as Zigbee or Bluetooth. But, this is a chance for everyone to take a look and try to employ it.